I've seen a lot of products also claim, there's no DevOps. You just use our cloud product, technology, framework, whatever it is, and you'll run without any DevOps. And we tend to think that if you're making that statement, it mainly means that you haven't run large enough systems.
This is DevOps Paradox, episode number 169. How to reduce cloud development complexity. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, how often do you open your IDE to write code?
I never open it. It stays open all the time.
And it doesn't crash your machine anymore?
That depends. When I open it as many times as I have to restart my machine to update it.
Oh, so once a year?
No, with Mac actually now you need to upgrade it like at least once a month. It's annoying.
And you might be asking, why are we talking about IDEs? Well, we're talking about developer workflow. Wouldn't it be nice as a developer to be able to just write code, maybe sprinkle in some annotations, and then bingo, bango, you have a cloud native application? Sounds a little too good to be true, doesn't it?
It's actually something that I think that we've been trying as industry for a very, very long time, but not necessarily successfully, right? If you think about it, isn't that Heroku in a way?
Yeah, sort of. But Heroku is the runtime, not the writing of it.
Yeah, but kind of you write your app, you say whatever the command was, and you get it there. Now, Heroku failed. I know that many people do not agree with me, but the intention existed, I think. Now the question is, how are we going to get there? Do we want to get there?
We have a couple of guests on today to maybe help us get there. We have Aaron Torres and Ala Shaban on from Klotho. Help me. Is that correct?
That's
correct.
That is correct. Klotho.
Okay.
Klotho. It's mysterious enough.
Okay, good. I could. Well, no, I can't do impressions, so I won't even go there. But we have both of these guys on today to talk about this concept of, as a developer, I just want to write code. And that's the last thing I want to think about. So once you guys introduce yourselves, Aaron, you can start. Ala, you can go next. And then set up, what are you seeing of how developers really want to work today? And how should they be working?
My name's Aaron. I've been a professional developer for a little over 10 years across a few different companies. I started off at Los Alamos National Laboratory and sort of worked my way through to Riot, and then more recently at Klotho. I guess what I am seeing since I've sort of been here and have sort of been working on this is, what you guys were talking about earlier, Heroku and sort of the benefits of it. When I first heard about Heroku and first started playing with it, I felt the same way, right? I was like, it's kind of magical. Like you're just pushing your Git branch and all of a sudden your code's live and you're able to do stuff. And what really appealed to me when Ala first started talking about this product is that it sort of transforms a general purpose cloud into a similar paradigm, right? Like you are not thinking so much about the cloud you're deploying to, but you're getting all the benefits of a modern cloud, be it AWS or Google or Azure sort of out of the gates.
My name's Ala Shaban. I'm the co-founder of Klotho. And I used to be a software engineer turned product manager, extremely technical one, and was one of the product managers on Visual Studio and Microsoft, and then more recently joined Riot Games, and more recently led the cloud services org at Riot Games, where we had to build a platform that runs League of Legends and all the newer games for 200 million people everywhere around the world with every possible cloud workload you can imagine, on-prem, off-prem, China, low latency, high compute, hypercompute. We wound up seeing the complexity of building all of that. And then by the time we were done, the system or the platform was already legacy. And so that led us to try to understand why is it that this seems to be a cycle that happens every 3 years where something new comes along and then we take another 3 years worth of investment to get to the next thing. And Klotho tries to fundamentally change the paradigm, which breaks the cycle.
One of the things I believe that are symptomatic or important is that most of the previous attempts try to simplify developer experience from a very vendor-specific perspective, right? If I look at what we have today, I could say, hey, actually, we have that with Google Cloud Run, right? The only requirement is that it needs to be Google Cloud Run. We have that just as the only requirement of Heroku in the past was, hey, it needs to be Heroku, right? And then we have the other extreme that companies try to do the same things themselves and then very often end up in a mishmash of random things that are impossible to keep up to date over time, right? And I believe that we need something in the middle, right? It cannot be highly vendor opinionated, it must be Heroku type of approach. But on the other hand, it's completely ridiculous for every company to create their own bash scripts with thousands of lines of something that you execute and then you get something running somewhere somehow.
Yeah, I think there's a broader topic here, which is we kind of refer to Heroku, but there's a reason why Heroku didn't scale beyond kind of the smaller companies or the larger companies with very specific workloads. People migrate to AWS and other types of technologies, not just because it's not Heroku or because Heroku locks you in. I mean, you're locked into any other cloud you're using. Heroku doesn't make it easier to build distributed systems. You can build a single application, you can check it in, it can deploy, but once you have to break down a system into multiple microservices or have isolation boundaries and do everything that companies tend to do with either Mesos or Kubernetes or similar patterns, Heroku stops being useful. The level of complexity there outdoes any benefit that you can imagine from the ease of use that Heroku had. But once you go into that world, then running on AWS or Google Run or others don't actually make it simple. They just make it possible. When you use Google Cloud Run or AWS Lambdas or Kubernetes, you still have to deal with service discovery and you still have to use their specific APIs and you still have to figure out how to do, how do microservices live here? How do you do fault tolerance, etc. All those things are still in the purview of devs and ops. And so the solution needs to be something not that marries both, but actually abstracts them away into a higher level.
But we already have a solution. I mean, that's open a Jira ticket to the ops people. Then you get your application running, right?
I think while that may seem as if even it's possible, not really. I mean, that used to be a pattern where you do wall tossing. But if you think about it, having microservices talk to one another is not something ops does or do. That's usually something on the developer level that developers have to do. And they're usually facilitated by a platform team that writes the SDKs that can leverage their underlying platform.
Right. And I would also argue that was part of why DevOps started to grow and become a movement is because as microservices became more common, it became easier for the developers to operate them just because of the nature of how explicit and small a microservice is. And so you really started getting the division, or I guess more pushing ops down into the development stack was sort of the trend for a long, long time. And now I've seen a big shift back in the other direction where I feel like companies are trying to bring back operating teams and trying to kind of move things back in that direction and have something to manage it at a higher level, like service mesh and other things like that.
Yeah, that's also kind of common pattern that we have something, the same thing is we had full stack developers which I believe never existed kind of like in practice. What I'm trying to say is that every attempt to actually expand drastically the scope of what the person does sounds great on a paper, but always fails. You cannot be a full stack developer. So you cannot understand backend, frontend database and everything in detail, right? What is to me a real challenge is we need different expertise in a company, right? We cannot funnel all the expertise into a single person because that's physically impossible. Now, the real challenge here is how do we make those different experts work together in a way, right? That's the real challenge.
Yeah, I think the key concept here is separation of concerns. It's not eliminating one role or the other, meaning we're always going to need ops folks, and we're always going to need DevOps folks, and we're always going to need, or let me frame it differently. We're going to have three types of roles: devs, ops, and whoever lives in between to help facilitate both SREs or the platform folks. What's going to be different is the shift in percentages on what companies have in each function. We're going to have more devs doing dev things, and we're going to have less ops focusing on ops things. And in total, the platform and infrastructure teams are going to be smaller because the complexity no longer has to be spread thin and the expertise needs to be spread across all of the organization. But each function can focus on what they're good at.
Exactly. Especially if you actually start thinking about it from the business perspective. In an IT organization, devs are really making money because they're making applications that generate profit one way or another. Everybody else, and this will sound in a way offensive, but everybody else is a cost. Now, we cannot get rid of that cost, right? We need people managing servers, we need people managing security and stuff like that. But the more we can reduce that workload, the better, because effectively we are actually reducing the cost. Which I know that it sounds offensive to, let's say, ops people, we are a cost, but there's nothing wrong being a cost. It's just about managing it in a way and shifting as much as possible into whatever generates profit, and applications generate profit.
I would also say that's even more pronounced in the startup space where you have limited budget, and you're even more limited budget rather, and you're trying to hire, but you're competing with bigger companies that have big budgets, and like trying to staff all the positions you need right away can be very, very challenging, which has also been one of the things that we've seen some benefit from of people using our product so far.
Yeah, I've seen a lot of products also claim, there's no DevOps. You just use our cloud product, technology, framework, whatever it is, and you'll run without any DevOps. And we tend to think that if you're making that statement, it mainly means that you haven't run large enough systems. The way we think the future is going to look like is a spectrum of no ops to full ops. The larger the application, the higher the complexity. You're going to have to, ops are your best friends. There are some things that devs aren't good at, and they shouldn't be good at. And that's kind of the separation of concerns that we keep getting back to.
And part of, basically, with the introduction of cloud, part of ops, and I'm using it in a very broad sense of words, actually was reduced because part of it is now in AWS. You might not see it that way, but AWS is actually becoming part of your ops team. In a way, right? They're keeping your servers alive and quite a few other things.
Yeah, and specifically, it's not like magically automated. AWS has an army of operators literally running and making sure your services are running and dealing with live outages, other than the automation and the tools that they built. But it's literally them, having an army of ops folks.
Exactly. It's almost similar to what we had in the past when IBM would actually bring a bunch of people to your data center to manage your stuff. It's just that now it's physically not your data center anymore.
Now, I do think there is a pattern that, especially in the ops world and devs too, I think ops isn't going away. They're moving upwards the stack. You're seeing more folks write infrastructure as code. You're seeing more folks configure and run and operate larger systems, enable observability tools, etc. And those are still the platform and ops folks, or closer to. And they're just moving upwards from metal and networking gear and to moving upwards the stack, dealing with Kubernetes, dealing with those types of concerns.
That's not really much different than what is happening in any other area, right? I remember at the beginning of my career, I would be spending half of my programming time thinking and working around memory and CPU and what goes in which segment of the memory, right? And now I don't do that anymore. I mean, some people might, but simply we are always moving up the stack. And what I'm trying to say is that's not specific to ops. That's specific to almost every layer, right? If you were a security expert 30 years ago, you were much lower and closer to the real deal, to low levels than you are today, which is kind of great. Yeah, right.
So thinking back on some of the things you were just talking about, why do companies think that they have to build something complex for complexity's sake? Is that it?
No, it's actually necessary. I mean, okay.
Really?
So it depends on the company. Let's start with there. So we built a platform in Riot Games, and we did the technical due diligence on what did we need to build. There is a reason why companies build microservice-based architectures. For today's scale, in mid-sized companies and fast-growing startups, you start needing to have fault isolation, a way for teams to work separate, with more autonomy, and microservices make that easier. It comes at a cost. And I remind everyone that you can do anything with a monolith, you can do everything with microservices. It is just Turing complete, all of it. The main question is, which trade-offs are you willing to make?
Let's talk about some of those trade-offs. Because this is the big problem, because when we talk the simple Heroku thing, it's like, okay, I package my app, if I even have to package it, point it at my Git repo, and I'm done. But then obviously Heroku falls on the floor when we talk about adding in a service mesh and trying to figure out what are these things doing. So what are these trade-offs that we have to think about?
I mean, I can talk about some of them. The one of the more obvious trade-offs, I think, sort of historical coming into the modern era, is like the trade-off of working in a fully featured web framework, full stack, like Django, Ruby on Rails, et cetera, to transitioning to microservices. The tooling and everything was much worse when you first started, right? Everything was worse. Like your ability to debug your app, your ability to very quickly scaffold things, like everything felt archaic and kind of new again. And that's sort of the cost, right? Is every time we migrate to one of these new pieces up the stack, we move to microservices for the first time, all the old tooling becomes obsolete, all of our old practices become obsolete, and we have to essentially reinvent everything that we invented the first time through. So now tooling's starting to catch up, right? Like it's much easier to debug apps running in the cloud. It's much easier to attach and figure out what your logging is and all that stuff, because it's largely been figured out. But it took the whole industry years and a lot of money to kind of make that transition. So that's one of the trade-offs that we're kind of talking about here.
Going back to what you said about complexity, I would actually argue that today it is less complex to do stuff than it was 10 years ago. Now the problem is, actually there is small letters over there, the same things we were doing 10 years ago, right? When people complain about the complexity of cloud, of microservices, of Kubernetes, of this or that, what they often forget is that it is more complex because it is doing more complex things. It's not that it is more difficult to do today what we were doing 10 years ago. No, it is more difficult to do stuff today that we were not doing 10 years ago. Microservices give us certain capabilities, certain abilities that we do not have with monoliths. Are they more complex? Yes. But if you would try to accomplish the same objectives with microservices that we have with microservices with monoliths, I would argue that actually it would be more complicated to do it with the monolith. Scaling, distribution, fault tolerance, and all those things, if you would set the same objectives, I would argue actually that is the other way around. What we do today is less complex than if we would do the same thing in a way we did it in the past.
I think I come back to the type of application matters and the phase it's in matters. If we think about how monoliths used to be built, I see a lot of blog posts about how a startup went from monoliths to microservices and it was so much better. They re-architected the application along the way. And when you re-architect, you tended to build better software. I see blog posts that talk about how they moved back from microservices to monoliths, and now it's so much easier. They just, re-architected it along the way, reorganizing the code in a way that is easier to manage and build on. And so I think we conflate a few things where building better software is a true statement, period. It makes it simpler. And so now the question is, what is easier to do in microservice land versus monoliths, and what's easier in monoliths that isn't in microservice land? So for example, the developer workflow in monoliths is significantly easier and better. You get from zero to productive in a week. You load up, you check out the application and the modules that every team is writing. You F5 and it's working, all of it. And you can debug it. You have full context, stack traces. There's no need for observability tools. You have all of the context in the application. But it's easy for teams to not have clean API separation because the code is fundamentally all mushed together. And it's easy when you're shipping quickly to, maybe go and change this other file that a different team owns. And it's okay. The team agrees because we got to ship. 6 months later, it's beyond tech debt. It's spaghetti code. Now in microservice land, you get fault tolerance. You can scale units more easily separately. You don't have to. When you have compute heavy or memory heavy units, you can scale them independently and right size them better. But now observability requires a distributed tracing system, which has to go through across every microservice. And if one is missing, then now you have a blind spot. It takes months of a single engineer's time to go back and retrofit a microservice architecture. We like to boast that we now run thousands of microservices. Sure. But now when you want to change one thing, you have to change it in those 1,000. And if you have a running system, the organization isn't going to be excited about changing running code for a live system when it doesn't really have to. So new service mesh came out. Great. Is it really worth going back and changing your Netflix Eureka stack with Istio? Maybe, maybe not. How can you even test this at scale? So there's a lot of trade-offs. Microservices lend themselves well to having separate teams, build them in separate repos, and then each one deploys them separately, and it's all nice and dandy. That's useful.
Until it's not.
Until it's not, because now you have to ship a product, and you need to organize across different teams, and you need to coordinate a simultaneous shipping cycle. And so now you have to herd tens of teams to do something simultaneously. You have a live site? Cool. Let's wake up 15 teams because something's happening across that path. We need to start triaging and figuring that out because I don't know what the other person's service is doing. I can't trace it easily. Some things are harder. Some things are easier. It is trade-offs. Those are trade-offs. We have spaghetti code. We have the ball of mud of microservices. Things depend on each other. This idea that microservices are, decoupled completely and nobody needs to depend on each other is not true. Teams have to build on each other's as code.
Right. I would also say that although maybe microservices are more popular now and monoliths are kind of falling out of favor, you can still get a lot of the benefits of modern cloud with monoliths as well, right? Like you can still use all of AWS services. All that stuff is much easier. So to your point, Victor, of things getting better, I agree, but I think they got better for both. They got better for both monoliths and microservices.
Oh, yeah. And it's also important that to recognize what is the problem you're solving, right? For all I know, I might be actually trying to solve a problem that was solved 15 years ago. And then I might be just as well, maybe perfectly well suited to use something that exists for 15 years. Not really. But what I'm trying to say is that what I see very often, people going into microservices, into cloud, into Kubernetes, without having it clear that they want to benefit from those things. And then we are running into situations, what you mentioned, Ala, before. I start with monolith, move to microservices, then discover that that's not a good idea, move back to monolith, or vice versa. Doesn't matter. I'm not now going in favor of one or the other. But if you try to use technology or a process or something that is without understanding what are the benefits you're getting from that, then you're in deep trouble, right? Then you're just chasing whatever is fashionable, right? There is also a human factor, which in my head is probably more important. To me, the first question about monolith for microservices is, hey, how many people work? I'm perfectly fine with a monolith 10 people work on. I'm not actually fine in most cases, not always, and when I have 200 people working on a monolith, right? Then we have a real trouble. And it's not because one is better than the other, but because one is better suited for certain conditions than the other.
I think what we'll see moving forward, and kind of our hypothesis with Klotho, is that to deal with the complexity that we have today in cloud development, reducing that complexity isn't going to come from streamlining it. Meaning if we package things together nicely and we slice up the workloads and we squint for this workload, we build this tool and it works more easily. But the minute you grow up or do something else, it's a nightmare again. We think that the complexity of microservices is inherent to the architecture. And monoliths still have a difficulty dealing with a lot of the trade-offs that you get from microservices. And so we think the next evolution isn't one or the other. It's actually a superset. And we have to think about it as a superset, meaning it has to combine all the benefits from both architectures without regressing in any way. So you have to move upwards in the abstraction rather than trying to streamline what we already have. And that's what we're trying to do with Klotho, and what we're calling the architecture that follows microservices, serverless, monoliths, adaptive architectures. Because they fundamentally can adapt to changing underlying concerns, whether it's cloud technologies, whether it's all the way down to the communication layers, gRPC versus straight APIs or backed by queues. We start going back to working with event handlers and emitters and calling functions and being able to delineate which code runs where. So you have to be able to simplify the application model all up, but in a way that doesn't lose any of the benefits that we've already gotten accustomed to with existing architectures.
Something like separation of concerns, that should it matter for me as a developer if I write my JavaScript, Java, Go code, actually whether it is running in AWS or Azure, or whether it's running as Lambda or a Kubernetes application? I guess that's the real question. What should matter to each actor in a chain, right, that leads ultimately to production? And can we separate those concerns sufficiently so that I get everything without really caring about things that are irrelevant for me? Because let's face it, deployment method, whether it's running in Lambda or Kubernetes, for most developers, that's irrelevant. It should be relevant. Because if it's not irrelevant, then every developer needs to stop doing what they're doing and spend 3 years trying to figure it out first.
So I agree with you with a caveat. There's a reason why those technologies exist. Each one has a set of characteristics, especially in runtime characteristics, that matter for different types of workloads. The application doesn't necessarily have to behave differently, but its runtime characteristics may require one technology versus the other. For instance, one cloud service may have low latency, but scaling it is difficult or slow. Another could spin up many, many instances, but it has a slow cold boot or doesn't have the flexibility of configurability. So it comes down to what does your application need to, how it needs to behave in runtime to carry that workload. Now, today, we write magic specs that describe something very explicit on what that means. We explicitly pick a technology, and then we configure it, and then we use its APIs to get that runtime behavior. In adaptive architectures, we think that the way you need to describe those things are based on what actually matters for the application. What are those? So first, you need to help your code understand how it should run in runtime, what capabilities, what cloud capabilities you want to give it. And again, this is our variation of adaptive architectures. But more importantly, you need to be able to specify the requirements, the application level requirements, which allows an automated system to then reason about how to satisfy those requirements. I'll give you an example. If you had a function that its purpose, or a service that its purpose is to render video, how do you pick the technology and how do you configure it? Well, let's think about the requirement. The requirement of the service is for every 10 minutes of video that it renders in 1 minute. That's my business level requirement, the product requirement. That's what matters. Whether it runs on Lambda or Kubernetes or Fargate or Google or others is an implementation detail, or should be an implementation detail. Now, there are times, many times, where you want to constrain the system to use specific solutions for many reasons. What we can operate, the people aspect. Maybe you have a deal with Nginx and you want to use their technology. But outside of those constraints, an automated system needs to be able to describe or to figure out which systems to choose to be able to meet those requirements. Microservices are the assembly code of the cloud. They're low-level constructs. We need to go upwards.
You sort of started laying out what Klotho does. Give us a concrete example of, I'm a new developer, I'm sitting down, and I'm getting ready to write my code the Klotho way. What does that really mean?
You start writing a vanilla application, a plain application. So let's assume it's a web server, right? Just a simple API. You can start writing your application with your favorite framework. Let's say, for the sake of simplicity, let's take JavaScript and Express, but this can be other frameworks, other languages, and their idiomatic ways of doing them. You start writing your application locally, and you can run it, debug it locally, you can F5 it, all is well in the universe. Now you want to make it cloud ready. And so what you do is you start annotating your code, different portions of the code on specific lines, not as specs, but actual semantically annotating it. So for instance, you would go to the web server and you give it the expose annotation or the expose capability. And the intent behind this is, I want this web server to be exposed to the internet. And that's it. That's all you have to do. That's literally what you do as your first application in Klotho. You add one line of annotation, no specs. You compile it with Klotho. What comes out of the other side is infrastructure as code, a slightly modified version of your application, and a nice little diagram that helps you understand how your annotations affected the generated application. That's it. You literally add one annotation, you build a web server. Now you want to have persistent data. So the question is, what type of data or what type of data structure? So let's assume something simple like a key value store. We can take existing interfaces that are, again, idiomatic to the language or within the ecosystem. Let's say we take a vanilla map or an async version of a map, and we give it the eventually consistent key value store capability or the persist capability, specifically being a key value store. That's the annotation. Locally, you start using a map. Nothing is different. It's quite literally a vanilla application. But when you run it through Klotho, what comes out of the other side is, depending on the technology or the target you want, whether it's AWS or Google or other things too. Like, there's no reason why this wouldn't run on Heroku and other, DigitalOcean. There's no barrier to that. What comes out is a cloud native version that, instead of the map, is using an underlying system that maps to a distributed key value store, whether it's Dynamo or Redis or MySQL. It shouldn't matter from a development perspective, only from a runtime and from an ops perspective. And so that's what you get. As a developer, you add one more annotation that on your map that says, I want the persist capability, and I want this to be a key value store, and you're done. You now have a web server with persistent data, ready to deploy using Terraform or Pulumi. It doesn't matter. We output infrastructure as code based on what you need it to be. Does that help?
It does. So the infrastructure as code that you output, I'm assuming, is vanilla type of IAC, correct?
Yes, we fundamentally try and not invent a spec, and we want users and developers and operators to be able to modify it, change it, configure it, and most importantly, not have to worry about recompilations through having a pre-hook and a post-hook. We always assume brownfield. And so we want what we generate for you to be immutable. You can then take the constructs that we create and then assign them to your rest of the infrastructure as code you already have. So imagine a use case where you want the API, the expose capability to give you an endpoint, but you want to bind it to an existing domain or a custom domain that you have. Because we assume brownfield, we assume that we're not the center of the universe. And what you can do is take the API gateway infrastructure as code element and bind it to your existing infra as code to a custom domain that you bring from whatever underlying tech you're using, AWS or Google. But just by binding them, you get a custom domain attached to it. But we don't assume that we're the ones introducing a custom domain capability. We want you to use the entire strength of the infrastructure as code frameworks and not have us reinvent it.
It's interesting that you bring up brownfield. There's nothing much more brownfield than monoliths, and there's nothing much more greenfield than microservices. Looking ahead 3 years, are we going to see more of these stories that went from monolith to microservices and now is headed back to some form of monolith?
When we talk about, I think the microservices being greenfield, it depends on what you mean by that. At this point, we already have a good set of companies moving into microservices. We're beyond is it going to be microservices? It's where are you in the cycle? The minute you go into an existing company, you're not choosing what you want to use. Greenfield. You already have a platform. It already has constraints. It already has an SDK. At least in the best case, you have guardrails because you have to interact with the rest of the system one way or another. So it depends on what you mean by greenfield.
Well, I think that's the point I'm trying to make is there is no such thing as greenfield.
Agreed.
In today's world, there is no such thing.
Agreed.
There are biases and decisions that have already been made, unless you're just two guys showing up at a hackathon on a weekend. That's true greenfield. But I think even there, as we said earlier, you're still going to be bringing in the biases of what do you normally use.
Exactly. I mean, even if you start a new company today, you hire the people, you have 0 lines of code, you bring experience. That experience automatically becomes brownfield because I like Google Cloud. I'm not going to use Amazon, right? Or whatever combination you want. No JavaScript, everything is Go, right? Whatever that something is. So even without having any assets, it is already opinionated, and brownfield means that there are opinions, whether that's in physical assets or in biases. It's just different shades of the same thing.
And to your question, Darren, what would the model look like? We think it's going to look more monolithic from the application, the integration layer, and it can still be multi-repo or broken down into pieces by using or reusing modules. We're not inventing something new. These concepts existed 10 years ago. You had the application and you had different teams building different modules. It just tended to be mushed together. The way we see it is teams can either work in a monorepo fashion and include all the things in that repo. That tends to work well if you're still small. And as you grow larger, you start writing your own modules. I mean, the interface is the API service. It can be versioned using the package versioning. We already have all these constructs in the way we work in larger applications today in let's say, Maven or NPM. We already have versioning built in. What will change is the integration layer would import all these modules into what is the application. And each module will be annotated. And then that combination of all the different services or modules would be centrally compiled or kind of transformed into a larger distributed system. One of the benefits that gives you is local testing end-to-end. It gives you the ability to optimize, or for Klotho or a similar system, to optimize across the entirety of the application, something that even architects at this stage in a large application can't really keep in their heads. It's too many details. But because the integration layer brings all of it together and it understands what each portion is asking for from a capabilities and requirements perspective, now you have the ability to reason about the application as an application. Maintaining the benefits of each team works on their own piece. They can bootstrap it differently. They can test it separately. And then you get the full developer monolithic experience when you integrate all the things or when you depend on one another just by importing modules, calling the different API surfaces, just like you would develop today locally. Maintaining all the benefits without the downsides.
So if people wanted to get started with Klotho, what do they need to do?
They need to go to klo.dev. The website has everything you need, whether it's documentation or the CLI. We have a Discord channel if you have any questions. Keep in mind, we're still in early phases. We're still in alpha phases. While we are in production with a few companies, we're still caveating all of this, that this is technology that is early enough to warrant looking into it and talking to folks and making sure that it works for your workloads and maybe having a conversation with us on Discord, because we've been working on this for 2 years. So it's not we didn't start this yesterday, but the level of change and the level of benefit is so large that it comes at a certain cost of immaturity at even 2 years in.
And that is klo.dev. Ala and Aaron, thanks for joining us today.
Thank you for having us.
Thank you for having us.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.